Hello everyone. In this video, I'll be talking about the question substring with concatenation of all words. Another Leetcode hard question, and as I say in every Leetcode hard video, it is honestly a simple question once you figure out how to do it. At first, when I tried this, it was a little complicated to understand, but once I got the hang of it, once I started to gain a little momentum when I was trying to find the solution, it was so painfully simple that I was almost embarrassed that it took me so long to figure it out. But you don't have to waste all that time. You're here watching this video, so you've already got it covered. Let me help you out. All right, without further ado, getting into the question, you're given the string S, and we have an array of strings words that is given to us. All the strings of words are of the same length. That's just me reading the question out, nothing new and nothing too complicated as far as we've reached at the moment. A concatenated string, it says, is basically a string that contains all the strings of any permutation of the words concatenated. They've given us some jargon over here. What that basically means is that if there is a string, that string could be, let's say, something like cat, dog, man, dog, cat, something like this. Okay, if I have words that are dog and cat, this string could have dog and cat attached together in any permutation. So cat could come first, dog could come after, or dog could come first, cat could come after, like this one over here, this case over here, and this case over here. All right, they've given us a few examples. You can go through that when you try to solve it yourself. That's basically what they mean. We have to find out whether this string that is given to us as an input contains these words attached to each other, concatenated, that's the word they've used, in any permutation. And one thing to keep in mind is that this words array could also have repeated words. So this dog could also be present once again. In that case, you will have to find a string that has something like this present so that we cover two instances of dog, not just once. Now, where do I get this from? From example number 2 that is given to us. They have given to us an array in which the word is repeating once. All right. So that is what the question is about. Let's see how we can solve this. So I've written down a string over here for us. We have some words, cat and dog. I've written down a few variables to help us get started. All right. And before I talk about these variables, let me just talk about the approach. We are going to follow a sliding window approach. Basically, we are going to take a window, a small window of words inside this string. We'll analyze whether that chunk of string, that substring, so to speak, contains all the words from this array or not. That is the approach that we're going to follow. How are we going to implement it? That is something we'll see in the next video, but the approach that we're going to implement in the next video is what is being discussed right now. So we have the word map to start with. Word map will contain frequencies of the words given to us in this array. So what we'll do is we will loop over this array and we will store the frequencies of the words in this variable right here. So if we loop over this, we have cat. Is cat present in word map yet? No, it is not. So we will add it with the frequency 1 because we've encountered it once. Then there is dog. It is not present. So we'll add it over here. Let's say we encountered dog once again, then we would make this frequency as 2. But in this example, we'll stick with 1 to keep it simple for you to understand. Next is word count. How many words do we have in this array? And that is, we can count it over here. That's 2. What is the length of each word? Now, notice one particular thing in this question. It says that all the string of words are of the same length. So all of these words will have the same number of characters in them. Cat 3 characters, dog 3 characters. Alright, so word length is 3. Each word has 3 characters in it in this example. Then we have window size. Now this is where things get a little complicated. What should be the size of our window that we will check whether it is accurate or whether it is something that we want or not? That window is actually just word count, let's call it WC, into word length. So that's 2 into 3, that is 6. How do I reach this conclusion? Well, because the string that we will end up finding, it will have to be of 6 characters, right? Because we have cat, we have dog. We have to find substrings that have cat and dog in it. That will be of 6 characters only. Something like this over here. Alright. So that is something we have now calculated. And of course, we will keep an answer variable with us. This answer variable will be an array. And look at the output that they expect from us. They expect indices, the starting index of the substring that is found to be valid. Alright, so let's see this example. We have this example over here. They have given us index 0 and 9 for this input. You can pause and read this if you want, which means that our valid answer starts at index 0 and it starts at index 9. Alright, so that is why we need an array. We will be returning this as our answer. The question is, how do we actually calculate or find out the indices that we need to fill in this answer array? So we will loop. We will start the loop from the very beginning. We can use a for loop for this. So this will start from the very beginning. It will go all the way till the end of the string, but to optimize it, I can just say that it can go till the length of the string minus our window size plus 1 to cover all the cases. Basically, we want all the windows. That is why we have this +1 offset over here. Then we simply increment this 1 by 1, so that if we are taking a window, that could be, let's say, our substring will be 6 characters starting from the ith index, right? For I is equal to 0, that would simply be, and let's just keep a note of I just for our reference. I is 0 right now, so we'll take the first 6 characters because that is the window size. All right, so the substring is cat dog. Then what we'll do is we will implement a function, or you can just write it here as it is. What that function will do, or what that particular process will be, is that we will run a loop over this substring, and what we'll try to do is form a map. What will that map contain? This temporary map will check words of this particular length. So this will also be broken down. So first we will take out the substring of our window size. Then inside that window size, we have to basically test out for each word, right? That whatever word is being formed, that is obviously of this length, is it a valid word or not? So we take this word length, we loop it over. We check. First, we check for cat. Is cat a valid word in our map? If the answer is yes, which is true over here, we will add it to our temporary map, and we will of course keep storing its frequency. There is cat, its frequency is 1. Then we have the next word. We are done with this. We will move over to this part of this substring. We will check if dog is a valid word in our word map. If yes, then we will add it to our substring, to our object. All right, its frequency is stored. Then what we'll do is we will compare this temp with our word map. We will check each and every object, each and every key inside this object. We will check for cat. Is its frequency equal to the one in word map? If yes, great. Move on to the next one. Dog. Its frequency is also 1. We will we will check this over here. It's 1. Great. This is a valid substring. We will store its index, that is I, over here. Alright. So that's one. Then this loop will restart. We will reset our variables. Check for the next substring, which is this one over here. I won't go through all the substrings. Just to give you an example, I'll just go over this one, and that will bring us with the substring that looks like this. 6 characters starting from index number 1. Alright, so we will take out the first 3 characters. We will check whether this is in the word map or not. The answer is no, it is not. And that is simply telling us that this is not a valid substring, so we keep on moving forward. Now you'll ask this one important question when you're looking at this video, that okay, fine, I get that we are comparing the maps, but why are we comparing their frequencies? Can't we just compare whether the words inside this map are the same as the words inside this map? Well, in a general case that would be true, but I mentioned this one case, right, that the words can also repeat. That is why matching their frequency is also important. That is why inside a substring, dog should appear only once and not twice, because there could be a substring in some other example, which could be something like dog, dog. Here, dog will appear twice, right? That is not what we are looking for. It is an invalid string for us. That is why we have to also compare the frequencies. So we'll keep on doing this, and we find out this is not a valid substring for us, not what we're looking for. So we keep on moving forward till we encounter the next valid substring, and we will then put its index over here, and I think it should be 9. Yeah, it is 9, and that is what we have in our answer over here, and that's all that you're supposed to do. I'll repeat the entire process. You calculate some prerequisite values which are very simple. Then you loop over the entire string, take out a chunk that is the size of your window. Inside that chunk, try to break it down into words of our valid length. Check if that word is present in the map and is present with the right frequency. If yes, then that's great. We put our index in our answer, otherwise we move forward. Whatever is our answer at the end of the day, that is what we return. Alright, that's all there is to know in the theory part of it. In the next video, we'll be solving it, so stay tuned and follow for more.